Hi everyone. Today we're going to study trigonometric ratios of 0 degree and 90 degrees. Let's begin with trigonometric ratios of 0 degree. In the triangle ABC here, look at what happens to the trigonometric ratios of angle A. If angle A is made smaller and smaller till it becomes 0. So this is our final figure. As angle A gets smaller and smaller, the length of the side BC decreases. The point C gets closer to point B, and finally, when angle A becomes very close to 0 degree, the side AC becomes almost the same as side AB. Now let us use our final figure here to compute for the trigonometric ratios of 0 degree. Let's begin with sine 0 degree. We know that sine is opposite over hypotenuse. Using our final figure here, that will be BC over AC. We can see that the BC equals 0 over the side AC. So we simplify this as 0. That means sine 0 degree is 0. Now cosine 0 degree. Cosine is adjacent over hypotenuse. In the figure, we can see that will be AB over AC. We can notice that AB equals AC in this figure. Therefore, this is equal to 1. So cosine 0 degree equals 1. Next, tangent 0 degree. Tangent is opposite over adjacent. So that will be BC over AB. In the figure, we can see that BC equals 0. Divide by AB, that will be 0. Therefore, tangent 0 degree is 0. Next is the secant 0 degree. Secant is the reciprocal of cosine. Since cosine 0 degree is 1, so secant 0 degree is 1 also. Next is cosecant 0 degree. Cosecant is the reciprocal of sine. So in the figure, we can write here AC over 0. Division by 0 is undefined. Therefore, cosecant 0 degree is undefined. Next, cotangent 0 degree. Cotangent is the reciprocal of tangent. So in the figure, we write here AB over 0, and this will be equal to undefined also. So cotangent 0 degree is undefined. These are the trigonometric ratios of 0 degree. Now let's have trigonometric ratios of 90 degrees. Let's have this triangle. In the triangle ABC here, look at what happens to the trigonometric ratios of angle A. If angle A is made larger and larger till it becomes 90 degrees. So the figure becomes like this. This is now our final figure. As angle A gets larger and larger, the angle C gets smaller and smaller, and the length of the side AB decreases and closes to 0. Finally, when angle A becomes very close to 90 degrees, the side AC becomes almost the same as side BC. Now let us use our final figure to compute for the trigonometric ratios of 90 degrees. Let's begin with sine 90 degrees. We know that sine is opposite over hypotenuse. Using the values of the figure, this is BC over AC. We can observe that AB equals AC. So, the sine 90 degrees equals 1. Next, cosine 90 degrees. Cosine is adjacent over hypotenuse. In a figure, we can write AB over AC. We can observe that the AB equals 0. So 0 divided by AC is 0. Therefore, cosine 90 degrees is 0. Tangent 90 degrees. Tangent is opposite over adjacent. Using the values of the figure, that will be BC over AB. But AB equals 0. Therefore, BC divided by 0 is undefined. So, tangent 90 degrees is undefined. Then we have the secant 90 degrees. Secant is the reciprocal of cosine. Using the figure, we have AC over 0. And secant 90 degrees is undefined. What about cosecant 90 degrees? Cosecant is the reciprocal of sine. Since sine 90 degrees is 1, therefore cosecant 90 degrees equals 1 also. Then cotangent 90 degrees. Cotangent is the reciprocal of tangent. Using the figure, we can write 0 over BC. And this will be 0. These are now the trigonometric ratios of 90 degrees.